primates, rays, and sharks, they are called chondrichthyes. And chondrichthyes means they have a cartilage skeleton. So it's like no bones. No bones, and it's cartilage like you have in your nose or your ear. And it gives some shape to the body, but it's flexible, it's movable. So this is only 3% of all the fish are chondrichthyes. 97% of all the others are called osteichthyes. And osteichthyes means bony fish. So these would be your perch, your sailfish, your barracuda, your every other kind of fish. So it's like almost all of them are osteichthyes. Sharks, however, have a couple interesting features. In sharks, there is no air bladder. So fish have an air bladder that is a little bag full of air that it keeps it floating in one spot. Sharks don't have that. So sharks must keep swimming. They cannot stay in one spot or they'll just sink. There's no bladder that keeps them up. Okay? Sharks have a lateral line, which we've already talked about, these pressure-sensitive cells that feel small changes in pressure. Sharks also have a very keen sense of smell, so they can smell at great distances something that's in the water. Sharks are very nearsighted, so they have a hard time seeing anything until they get right up on it. And so they can't see far distance at all. So they depend more on their sense of smell. So the best strategy, if you fall into an area that has a lot of sharks in it, is if you're near a shark, go limp. Do not thrash. Do not try to outswim the shark. Go limp. And the shark will probably nose you, which I can think would be pretty unnerving to have a shark nose you, but pushing you with its nose, its snout. But that way you probably won't be eaten. A whale shark is one of the larger sharks. There's a whale shark and the basking shark. Both of these sharks are the largest ones. And a whale shark can be 60 feet long. So picture, a typical large classroom is about 30 feet long. Our classroom is about 30 feet long. So picture about twice that length, okay? A shark. And so that shark would be 60 feet long and about 8 feet wide. It can weigh up to 40,000 pounds. And it's a plankton eater. It just has it goes around with its mouth open, just collecting plankton. And this may be the kind of fish that swallowed Jonah. Now, we don't know, except that it says it was a great fish. This is a really large shark that does not have teeth, and if it did swallow Jonah, it could have swallowed him. Jonah could have fainted, passed out. He could have even been alive for several days inside the fish. In fact, this kind of fish has been found to have smaller animals. A small dog, a deer, one time was found inside a whale shark. So whale sharks can come up and swallow animals or Jonahs who are in the water thrashing around. A basking shark is also a plankton eater, and again, it's one of the larger sharks. And then we have the great white shark. Now, the great white shark is not a plankton eater. This is a man-eater. This will eat lots of flesh. It's the most deadly of the sharks. There's a great concentration of great whites near Australia. It can be about 21 feet long. So you can tell these are really, really large fish, but nothing like a whale shark. Okay, and it's near Australia is the big concentration. Australia weighs about 3 tons. It can reach 6,000 pounds. Now, those are the sharks, and they're interesting animals. The bony fish, the osteichthyes, we mentioned before, is about 97% of all fish, and this would be sunfish, freshwater fish, trout. We mentioned perch, halibut, catfish, sailfish. You name it, all these other fish are bony fish. And they have the air bladder. They are able to stop swimming and just stay in the calm of water, not drift down or up. And they have an air bladder that is located along their belly, okay? It's like a ballast chamber. Like a submarine would have a ballast. See if I can spell this word. Ballast. There we go. Chamber in a submarine. So the submarine will pull in water and it'll sink, or it'll push water out and it'll rise. Same kind of thing. Same method as the way this air bladder works. Let me go ahead and draw a quick picture of a bony fish. And of course it's got its anterior dorsal, posterior dorsal, its anal fin, its pectoral fin, its 2 pelvic fins. So the air bladder sits right about where I'm drawing there near the belly of the fish. I'm sorry, that's not where it is. That's wrong. I don't know why I thought that. It's actually located right up here. It's near not far from the backbone of the fish. So let me label that. That's the air bladder. Okay. So fish, very, very interesting group. Now we're going to look at some of the other animals that are present in the fish and in the ocean with the fish, and they are various. Wow, we have a tremendous number of these fish and different animals. So this first picture, actually, let's look at sharks versus fish first. It's a handout, and it shows different attributes. Sharks For their skeleton, they only have cartilage. The fish have bones and cartilage. For swimming, the sharks can only swim forward. They don't have any pectoral fin. The fish, though, swim forwards and backwards. Buoyancy, the sharks only have a large oily liver. They have no swim bladder. For skin, the sharks do not have scales. They have a very rough, sandpaper-like fish. I don't even think they really are scales. It's more of a leather. Whereas fish have slippery, slimy scales that overlap each other. And gills, the sharks have gill slits, no operculum, but the fish have covered gill slits and operculum that covers their gill slits. So there's a little bit of information there. Now, in terms of animals, let's take a look at this first one. It's called the Colenorata, or colenerates. Colenerates have radial symmetry. Now, you can just follow along on your page here. You need to know these, several of these. I would say know 3, maybe 4 of the characteristics for each one, because we're going to look at colenerates and mollusks and echinoderms. So just take a look at those, and let's look at the colenerates first. They have a radial symmetry. That means it's a round symmetry, and they're often bell-shaped or even umbrella-shaped. So a medusa is an example of a colenerate. That would be on a jellyfish. So the medusa is that beautiful umbrella, clear, kind of pulsating part of its body. Now, if it's tube-shaped, that's the polyp stage, and you have a long kind of like a tube, and the stinging cells on these animals are along the arms, and they have little nematocysts, which are tiny little, basically barbs. And each barb, when it touches something, inserts a poison. There's only one hole that goes into the colenerate, and it's where the mouth is, and they also expel waste out of that hole. So it's just one hole going in, one hole going out. Now, they do have a hollow body cavity, and some live singly, some live in colonies. This kind of depends. Some swim about freely, like a jellyfish. Some others are attached to a substrate, like a rock or a pier, and that would be like your sea anemone. So examples are the hydra, the sea anemone, the jellyfish, the coral. All of these are colenerates, or a colenorata. Sometimes you'll hear that phrase as well. So I'm going to write that on the colenerate. Or colenorata. Now this would be an example, would be your jellyfish. I'm just going to put that down as we remember that these are things that there's no backbone. They just have a polyp, and it's often a hollow organism. Our second group are the echinoderms. And derm means skin. Echino means having little barbs or spines. So this literally means spiny skin. So these have little small projectiles, spiny skin. Let's take a look at some of the examples as your starfish, and you have your brittle stars, your sea urchin, all these little spines that stick out. And your sea cucumber is also one of these types. It's an echinoderm. So it is radial symmetry. They are marine mammals. Animals, marine animals. Most have a spiny skin, and they have radial nerves that extend into each arm. Water-filled canals are connected to tube feet, so they can walk around and stick to objects. So examples would be your starfish, your brittle stars, sea urchins, sand dollars, sea cucumbers. Interesting group. Our third group are the mollusks. And mollusks are very, very interesting. They have a part of their inside, they're usually in a shell, but they have a muscular foot. And so that's what you want to think of with a mollusk. It's got a muscular foot, which is something that's pushed down into the sand. And so I can spell that a little bit better so you can, there you go, muscular, there, foot. And so the foot is this muscular piece of flesh that they push down into the sand, and it propels them. So a clam has one. It enables the clam to dig down into the sand, as an example. Okay? So they have bilateral symmetry, meaning if you cut them down the middle, there's two identical sides, two mirror images. They're usually shelled, and some have a single shell. Some are univalves, like gastropods. Now, a gastropod is one that's like a snail. Okay, so your snails are gastropods, and that foot is the part that extends out and kind of sticks to a surface and pulls the snail along. Okay, they have gills to remove oxygen from the water, and their muscular foot is used for locomotion. It may be divided into tentacles with suction cups. They have a mantle that produces a hard shell. Water is expelled through a siphon, so they may be used even for jet propulsion. Many bivalves produce pearls. Examples of these mollusks include clams, snails, the squid, and the octopus. You might think, well, why is an octopus? How does a squid? Well, they both have these tentacles, and they have a muscular foot. They have a muscular pad that they can stick out and propel them and push them through sand. Another group is the crustaceans. Crustaceans. And the crustaceans are those that have an exoskeleton. You see their skeleton on the outside. So they're going to have a hard, kind of segmented, armored look to them. A little bit like some animal that we know that has plates on the outside. These are marine animals, so like a lobster would be an example. Okay, crayfish. They have bilateral symmetry, so you can cut them down the middle. There's two mirror images. 5 pair. Now here's an interesting thing. They must have jointed legs. And so that's the key thing, is the exoskeleton and the jointed legs. They have jointed legs. They are very fascinating animals. They have specialized appendages, so they have chelipeds, which are those big claws. They've got smaller, different kinds of maxipeds and different names of the different appendages. And so, interesting, very interesting. They even have an antenna. So they have 2 pair of antennae. So I bet you didn't realize that a crab had antennae, but it does. They have distinct eyes. Their eyes are usually on a stalk, and they stick up, and so they can get a good look around. So they have kind of extended eyes up on a stalk. And they have 2 body sections, a cephalothorax and an abdomen. Sometimes a claw is used for eating and defense. As an example, with a crayfish or a lobster, that large claw, the cheliped, if you get grabbed by that, you know it. We will take our juniors and seniors sometimes sign up for the special trip that we take to Washington, D.C. and in Virginia, and we go out into the water on 2 or 3 of the days. I think it's 3 days at the end, and we go into Chesapeake Bay, and sometimes you feel these little crabs crawl over your feet. And sometimes they'll grab a toe, and you know it. It doesn't cause anything, but it's uncomfortable, and it pinches. So those are a lot of fun. Now, this is a good point for us to look at the human integumentary system. And the integumentary system is the skin and the organs in the skin. And so the skin performs several functions. It keeps the body bacteria free, so it's a barrier for bacteria. It also holds in moisture so we don't dry out. It holds in moisture, and it keeps and maintains our temperature. So I'm going to put T degrees. Our temperature is steady. So the skin is really, really important, and it basically does everything in terms of maintaining homeostasis. Homeostasis is a stable body environment. A stable body environment. So, for instance, if you were to get a serious cut and you lose blood, you're dehydrating, and of course bacteria enter the body. That's going to mess up your homeostasis. You could lose blood pressure, you could lose, and you will, because you're losing blood. But then you've also got bacteria coming into your body. So a loss of homeostasis, a loss of this stable body environment is life-threatening. And basically, we call a loss of this homeostasis, this is called shock. So your body goes into shock, your blood pressure goes down, your heart rate goes down, your body temperature goes down, everything goes into shock. And shock is present in any accident. So even if you fall off your bike, you get shock, you're emotionally shocked, your blood pressure, your pulse goes up, your blood pressure goes down, whatever, but it's present in any accident. So you always treat for shock. I know we've talked about, you probably remember first semester, we talked about raising the feet, laying down on a ground, putting a blanket, keeping your temperature steady, raising the feet slightly. That's treating for shock, okay? So homeostasis is a key word, homeostasis. It's a stable body environment. So if you lose your blood pressure, if you lose your temperature, if you lose your fluids, you're dehydrated, any of those is called a loss of homeostasis. You've gone into shock. Well, the skin protects against that. Let's take a look at this beautiful diagram of skin. I'm going to just draw a real crude diagram of what you have. It's got a big hair follicle going right here in the middle, and you can see that there's also this follicle structure, kind of looks like this, and you've got various features. You've got a sweat pore. You can see this sweat pore, and then there's this squirrely thing down here which brings the sweat to the surface. So you have a sweat pore there. You've got a hair that reaches up through there. You have the hair follicle. This is the follicle, which is kind of like the slot that holds your hair. You've got a muscle that actually extends here, and it is a hair erector muscle. So it's an erector muscle. It pushes the hair up so that it rises up, and the hair will stand on end. You know, when you're cold, you have goosebumps, your hair stands on end, etc. You also have nerves that are in your skin, and these nerves exhibit, as you can see on your diagram, number 4, here's a pain receptor. Okay, you also have a touch receptor. You can see that in number, is it number 2? No, number 12. There's a little touch receptor. And there's a heat receptor. That would be your touch receptor. And so lots going on in the skin. And the skin really is divided into 3 sections. There's this upper portion, this really thin portion that runs along the top, that's dead tissue. And this is called your epidermis. So the outer portion of the skin is dead. It is dead tissues. And so if you scrape yourself, usually, you know, you have this like this whitish scratch on your surface of the skin if you scratch yourself. And if there's no bleeding, all you've done is scratch this upper layer of the epidermis. It's a protective layer. We lose epidermal cells all the time, and so it's designed that way. We're designed to kind of flake, to have little flakes that come off from our skin. Below the epidermis, you have this dermis layer. And if you notice, the dermis layer reaches down about this far, and this is the dermis. Now the dermis is a complicated layer, and then below that you have the subcutaneous layer down below the dermis. And the subcutaneous layer is where you have, is actually the most complicated of layers. It's here where you have your sweat pores are down here, the base of your nerves and your capillaries, all of that. Now the blood vessels do reach up into the dermal layer. So if you cut yourself, that means you've cut into the dermal layer and there's bleeding, okay? And so you have a number of complex things there, but the most complex layer is the subcutaneous layer. It's this layer down in here, okay? Now, what about sunburns and all? Well, if you get a sunburn, it's just reddening of your skin. That's called a first degree burn, and it really is just a burning of this top layer. So it's the burning of the epidermal layer, okay? And so there's because of that, you have some peeling, it's uncomfortable, it hurts, there's some kind of a fiery, painful thing, but it hasn't really gone into the dermal layer, so it's not endangering the skin or the body in any way. However, and so they'll call that a first degree burn. That's a first degree, is a sunburn. Okay, if you get a second degree burn, the burn actually goes down into the dermal layer, and the dermal layer is very serious. A second degree burn is usually it looks like a bubbling of the tissue. The tissue has sort of raised blisters. So there's white blisters that have occurred, and if they pop, then you're open to infection, you're losing fluid. So your second degree burn is a serious burn. You have to lightly wrap with a sterile bandage, and you have to keep it clean, and you want to be very, very careful with the second degree burn. So people that have a really bad sunburn can have blistering on their shoulders. I've had that one time, one day here in Albuquerque, out in the sun all day, and I didn't have any sunscreen on, and it blistered on my shoulder. So it's a little bit scary to see these white blisters. Now, a third degree burn reaches into this third layer, the subcutaneous layer. And so when it goes down into this third layer down here, you have a charring. The burn is so bad that it chars the skin. It turns it black. And you have sort of ashes that begin. So that's extremely bad. There's shock involved here. You've lost fluid. You're definitely open to infection. This is the real very, very serious burn. So you have to treat that with extreme caution. You have to treat, of course, you treat any of these burns for shock, but this person could die. I mean, this is life-threatening right away. There's a loss of homeostasis, and so there's got to be very, very careful. So your first degree, second degree, and third degree. First degree, again, is reddening of the skin. Second degree is a blistering, white blisters, and a third degree is a charring. There's a black charring of the skin, and a loss of homeostasis. So be careful.